Hello everyone. Today we'll be doing vector and scalar quantities. Without further ado, let's begin with vectors. Now, vector quantities such as force or velocity are quantities in which we have to take into account not only the magnitude in the number, say 5, but you also have to take in account the direction. So, for example, if we have force being pushed in the right direction, and we assign a value of say positive 5, and then we have another force being pushed in the left direction, and we assign the value of 5, we will now take into account the directions and assign one direction a negative value, so we can make this one negative until this one is positive. So in other words, if if one of the bodies or one of the magnitudes is going in the exact opposite direction, it has to be negative. And you can also take into account it with regard to angles. So if we have force being applied at, let's say, a 45-degree angle here, we can actually find the force in relation to this line called the horizontal component of the force, and we can find it in relation to this line called the vertical component of the force. Find the horizontal component of something, you will multiply this one here, call this f, by cosine. So we'd say horizontal component equal to f cosine and theta, the angle in there. And for the vertical component, now you'd say f sine theta. Now, scalar quantities, they only have magnitude. So for example, temperature is a scalar quantity because there is no direction for temperature. Temperature is just there. Now moving on to quantities of motion. Now let's go ahead and define these very clearly. Distance is a scalar quantity that refers to how much ground the body has covered. So let's say, for example, this line right here is a road that's about 100 meters long. This line right here is a road that's about 100 meters long, and someone traverses the entire road and then comes back halfway and stops right in the middle at the 50-meter mark. That person distance will have been 150 meters, 100 from start to finish, as well as the 50 to go back to the half mark. So that's distance. Now, displacement is a vector quantity that refers to the straight line distance from a body's starting point. It's just how far you are from wherever you started. So let's say if that same person were to do it again, traverse the entire 100 meters and then go back halfway to the 50-meter mark, their displacement would only be 50 meters because they would be 50 meters away from the starting point, which is here. If a person starts here, traverses up like this, and then ends up over here, move this way and end up over here, the distance would be this length plus this length, while the displacement would be this length, i.e. the straight line distance from the starting position. Now, the speed is a scalar quantity that refers to a body's distance per unit time. So speed is equal to distance over time. And you must remember that when you're using speed, it must be distance. Now velocity is just the vector version of speed, and so velocity is equal to displacement over time. If you're using speed, you must use distance. If you're using velocity, you must use displacement. Acceleration. This is a vector quantity that refers to a body's change in velocity per unit time. So in other words, acceleration, we'll call it A, is equal to final velocity represented by v minus initial velocity all over time. And this is for uniform acceleration. This right here is a very important equation that you need to know. So let's just go over that. So displacement is the straight line distance from a starting point, while distance is the how much ground you have covered. Speed is just a scalar quantity that refers to the distance per unit time, and velocity is the vector version of speed. And acceleration, the change in velocity per unit time, which means that if a body has constant velocity, there is no acceleration. That will be all for this video.
Tell me pretty lies, look me in the face, tell me that you love me.